sit right there because I'm going to be kind of standing right here. Yeah, well. You okay?
I want to make a quick getaway.
Uh-huh, uh-huh. Thanks, Liz.
If everybody wants to move on in and find a place to sit, we'll get started here on time. First of all, I want to welcome you all to the 2016 World Dairy Expo. And today's seminar, Achieving High Pregnancy Rates in High-Producing Herds, is being sponsored by Feed Supervisor. And our speaker today is Dr. Paul Fricke, professor at the University of Wisconsin-Madison. And just a little bit about us. I'm Keith Sather with Feed Supervisor, and we're extremely excited to be part of this presentation today as our client base with Feed Supervisor, especially here in the state of Wisconsin, is going through big changes now with BST leaving our market. And our guys are really interested in this talk today as far as saying how do I continue to achieve a high level of production and realizing the importance of reproductive efficiency in that scheme. So with Feed Supervisor and Hoof Supervisor, we're excited to be a part of this presentation today because it is often believed that high milk production is antagonistic to an excellent reproductive program in a dairy herd. And Dr. Fricke is going to give us an overview today that basically says, hey, we can have both, and we have to have both. So Dr. Fricke joined the faculty at the Department of Dairy Science at the University of Wisconsin in 1998 and was promoted to professor in 2009. His research program focuses on understanding the biological problems presented by modern dairy cattle. His goals are to improve the reproductive efficiency of dairy cattle by applying knowledge gained through scientific research and to develop a practical management strategies to assess new reproductive technologies. Today, I want to remind you to turn off your cell phones, and it's also to be pointed out that this seminar has been approved for continuing education credits from the American Registry of Professional Animal Scientists and the American Association of Veterinary State Boards program. And forms are available in the back, just outside the door, if you need those. And with that, Dr. Fricke.
Thank you. You guys are really polite. Here in Wisconsin, they usually only clap after they've heard what I've had to say, and they like what I have to say. So you guys are very, very polite. It's great to be here at World Dairy Expo. So this is my backyard, and I get asked to do these talks here every so often, so it's really a privilege. So I just want to thank Liz Matzke and the staff here at World Dairy Expo for inviting me to speak. So it looks like we have a pretty diverse audience in the room. So how many of you are from a foreign country? Raise your hand. Wow, look at that. That's pretty good. All right, how many of you are from Wisconsin? All right, go Badgers, right? How many of you are from Minnesota? All right, we're going to go slow. Okay, we're going slow for the Minnesotans in the room, okay, so we don't want to go too fast for the Minnesotans. How many of you are from a state other than Wisconsin and Minnesota? All right, welcome to Madison. You guys are here and having a great time, hopefully. So the talk that I want to give today is on achieving high preg rates in high-producing dairy herds. And before I get into my talk, since some of you may not have heard me speak before, I really have to introduce myself. How many of you have ever done a Google Images search? You ever got on Google and done a Google image search? You guys know that you can do this, right? So my daughters, a few years ago, were doing a Google image search for a project at high school. And they typed into Google Wisconsin and cow. Now, what do you think is going to come up if you put in Wisconsin and cow into a Google image search? Anybody. This is audience participation. What's going to come up on a Google search if you do Wisconsin and cow? You would think pictures of cows. You know what came up? I came up. A picture of me. So if you don't know me, I'm like the Wisconsin cow guy. Okay, I work with reproduction, and I tried this last night. Again, this was a few years ago. Google must have tightened down their algorithms a little bit because it didn't work last night. So if you go home and try it, but at one point in time, you put in Wisconsin and cow, and I came up on the screen. Okay, so we want to talk about reproduction. I want to cover a lot of different concepts today about our understanding of reproduction and some of the programs that we use. And I want you guys to think, how many of you have cows at home? Cows at home. I want you guys to think about these two animals. So that's a lactating dairy cow, a very nice one, a high-producing lactating dairy cow. And this is a non-lactating dairy heifer. Which of these two animals presents the problem for reproduction? Okay, so both. My friend up here from Ecuador says both. Okay, so that could be an answer, but that's not the answer I'm looking for. Okay, so there's good answers and there's not so, well, I'm just kidding. So anyhow, which of these animals is the problem when we think about reproduction? Is it the cow or is it the heifer? Okay, the lactating dairy cow. And so let's think about the differences between a lactating dairy cow and a non-lactating heifer. What are the possibilities for the potential differences? And in fact, let me just show you. These are some data. We do a lot of studies. You'll see a lot of data that I'll show today from my colleague, Dr. Mila Wiltbank at the University of Wisconsin, from my laboratory. When we look at these parameters of reproduction, for example, like estrus duration, cows are in estrus for a shorter period of time than our heifers. If you look at conception rates, generally less than 50% in cows, generally greater than 50% in heifers. If you look at pregnancy loss, pretty high in cows, pretty low in heifers. These two are an interest of mine as well. This multiple ovulation rate and twinning rate, pretty high in lactating dairy cows, pretty low in heifers. So there are clear differences when we start to measure reproduction between those two animals. Now, can that be explained by genetic differences? Are cows genetically very different from heifers or quite similar to heifers? They're actually quite similar. They're a generation ahead, but it's really not a genetic issue. And I say that because in some parts of the world, they'll make the argument that the high-producing dairy cow is not fertile because we haven't selected for fertility. And it ends up in the United States, about a third of our net merit index is, in fact, selecting for fertility. So I'm going to argue that this is a physiologic difference. Can anybody tell me what that is? So we've got a bunch of reproductive biologists out here. I know these guys. They're from Mila Wiltbank's lab and a couple guys from my lab. This is a steroid hormone. Does anybody want to guess which one that is? Come on, guys. What is it? It's progesterone. Now, I'll just tell you that if I ask a question, if you answer progesterone, you're going to be right about 90% of the time. Because the role of progesterone in all of this, we have found to be extremely important. So let's talk for a minute about progesterone. That's an ovary. I'm holding it in my hand. And the two structures on the ovary that drive the reproductive cycle are the follicle. The follicle produces another steroid hormone called estrogen. It also contains the oocyte that is shed at ovulation. After ovulation, then the follicle, the tissues that make up the follicle, turn into the corpus luteum. And the corpus luteum is the structure in the female that produces progesterone. Okay, so that's about as much as we're going to talk about where progesterone comes from. Now, this is some data. I like to kind of teach from actual data that has been generated. Roberto Sartori is actually in the room. Raise your hand, Roberto. Great study. I show this data all the time. And what it is a comparison between non-lactating heifers and lactating dairy cows. On the left panel is luteal tissue volume. Okay, so how big is that corpus luteum when it grows? And so this is day of the estrus cycle. So what Roberto did during an estrus cycle, he scanned a lot of heifers and cows. What you'll notice is that heifers have much larger, or excuse me, cows have much larger CL than non-lactating heifers do. So the CL in cows gets very large compared to a non-lactating heifer. Now remember, the CL produces progesterone. On these graphs then, in the same animals, Huberto measured progesterone through the cycle, and lo and behold, despite the fact that heifers have smaller CL, they have much higher levels of circulating progesterone. So if progesterone comes from the corpus luteum, cows have big CLs but low progesterone. Heifers have small CLs but a lot of progesterone. You start to think about what's the problem. Well, there's two things that regulate progesterone in circulation. One is production. The other is metabolism. So if you take a pharmacology class, they would teach you that. And it ends up, the big idea that I want to share with you guys is an idea that Dr. Milo Wiltbank has proposed for many years now. He's my colleague at University of Wisconsin-Madison. And it goes something like this. I want you guys to think about your highest producing dairy cow on your farm. So you got it in her head? What can that high producing dairy cow do better than the other cows in your herd? What's the fundamental thing that makes her a high producing dairy cow? I'll tell you the answer that I'm looking for. She can eat. Cows make milk out of feed. So here's kind of how this goes. Now, I'm a reproductive physiologist. That's as good as I can draw a rumen. Okay, so if there's nutritionists in the room, I apologize. That's a rumen. So high feed intake is highly correlated with high milk production. You can't really separate those two things apart. Does that make sense? You can't have a high-producing dairy cow that doesn't eat. So those two things go hand in hand. You could make the argument that our high-producing dairy cows were actually selecting for the ability for feed intake and conversion of that feed into milk. So really what Dr. Wiltbank, his kind of big idea here is that when high-producing dairy cows eat a lot of feed, they increase their blood flow to the gut. So if I was giving this talk after lunch, you guys would be falling asleep. And in fact, I see some eyes closing right now. I'm going to have to get a little more excited up here. Okay? So, after a big Thanksgiving dinner here in the United States, you kind of just want to go to sleep because your blood is being diverted to the gut to deal with all that feed. Where does the blood go when it goes to the gut? The first place it goes is through the hepatic portal vessels to the liver, and the liver ends up metabolizing ovarian steroids. It clears them out of circulation. And so what we end up in a high-producing dairy cow, again, this is the big idea. Okay, if you want to understand my talk today and everything that follows, the big idea is that high-producing dairy cows have high feed intake, and that high feed intake ends up with lower levels of circulating estrogen and progesterone in circulation. So we've kind of changed the endocrine environment of the high-producing lactating dairy cow. The rest of my lecture really is going to talk about how changes in estrogen and progesterone affect reproduction, and then what we can do about that. And there's certain things that, in fact, we can do about that. So this would be something, if I'm teaching class at UW-Madison, I'm going to say this is on the quiz. That's on the quiz because that's the big idea that we're dealing with here. So what about milk production? Do you think milk production in lactating dairy cows is going up? Yeah, milk production is going up. This is, I hate to show this, this is a guy from Michigan State University. You can see Sparty up there, but Wisconsin beat Michigan State, right? So this is actual milk production in the United States from 1945 to 2015. And this is Jack Britt put this together. He's an emeritus professor. And so what he showed is if this is the baseline in 1945, it took from 1945 to 1970 for cows to double in milk production. From 1970 to 2005, milk production doubled again. If you project out, if you just project out this line would be if nothing changes with this increase. By 2055, milk production is going to double again, and average milk production on a herd level will be almost 40,000 pounds.
Is that going to happen?
I do not know if that's going to happen or not, but I'll tell you what. I always ask the question, to geneticists, is milk production going like this? Are we getting to a genetic potential, in other words? This line would not show that, would it? This line is showing that that line is trending upward, and it's going to keep going upward.
Yeah, but to produce that 39,000 pounds of milk, how much feed intake, or where are you going to get that feed intake?
Yeah, I think that's a really good question. Obviously, this is not for sure what's going to happen. This is only what's going to happen if the increase in milk production that we've seen across these years continues. So I don't know if it's going to take a turn for the worse or if it's going to get better. I think, though, we can safely say that milk production in 10 years or 20 years is going to be higher than it is now. Can you agree with that? Okay. So here's the deal. Milk production is going up. Feed intake is going up. So if anything, we're going to continue to see some of the issues that I'm going to talk about in this particular talk. Again, I'm trying to lay the foundation for some of these concepts that I want to talk about. So now I'm going to switch gears into kind of a little bit more practical data. And I'm a reproductive biologist. I also have an extension appointment. I'm often asked to go to farms and look at reproductive performance. And so when I go to a farm, there's two questions that I always ask the farm. The first question, how and when are cows submitted for first insemination? In other words, what is the plan that the farm has in place to put semen into cows? Because my key to reproduction is a pretty simple one. In order to get a cow pregnant, what's the first thing you have to do? You got to put semen in. They gave me a PhD for knowing this, okay? In order to get a cow pregnant, you got to put semen into the cow. And so what is the plan for that to happen? So I'm going to first talk about technologies for increasing what I call the service rate. And then I want to get into this newer concept, which is kind of these fertility programs. So we'll talk about that. Now, all of our cows get pregnant at first breeding, so now we're done, right? No. So if you get key number 1 in place, we go to key number 2. How and when are non-pregnant cows identified and then re-inseminated? So I want to talk just a little bit about programs and technologies for non-pregnancy diagnosis. There's some exciting new stuff out there. At the end, we'll talk about programs to re-inseminate the non-pregnant cows. This is something that I want to be very clear in my talk. There is not one single way to accomplish this on a dairy. I have seen many dairies that have different strategies for getting these two things done that do well with reproduction. Okay? I'm going to try to show you a variety of those strategies today. So don't think I'm being prescriptive that I think that there's only one way to do this. Okay? So there's many different ways we can do this, but I'll tell you, you got to have a plan. You got to have a plan to put semen into cows. You got to have a plan when to identify them as non-pregnant, and a plan when to get them re-inseminated. Before I get into the meat and potatoes, then we have to talk about measuring dairy herd fertility. So reproductive performance on a dairy is determined by how rapidly the reproductive management program turns open cows into pregnant cows. Do you agree that that's the goal of reproduction, right? Turning open cows into pregnant cows. What is the best way to measure that? How are you guys measuring that? And this is audience participation in my talk here today. I know there's a lot of people in the room. Okay, 21-day pregnancy rate. This is the metric that we are using. If you go to most farms in the United States now, they can tell you what their 21-day pregnancy rate is. Now, I put this up here because in some countries they're not measuring the pregnancy rate. Pregnancy rate, the 21-day pregnancy rate, measures the rate at which eligible cows become pregnant per 21-day period of time. Okay? So it's really measuring how fast the cows are turning from open cows into pregnant cows. If your preg rate is not where you want it to be, there's two different rates that control it. The first rate is the service rate. It's the rate at which we can inseminate cows. Every 21 days, cows are going to come into heat. At what rate can we put semen into cows? That's the service rate. We used to call it the heat detection rate when we just watch for heat. We have ways to breed cows that don't come into heat. Once you service a cow, then fertility takes over. I call this pregnancies per artificial insemination. You'll see this on my slides, pregnancies per AI. It's really also interchangeable with conception rate. So some of you might have called that conception rate. I'll call it pregnancies per AI. So here's a question for the group. If your preg rate is not where you want it to be, is it easier to increase the service rate or pregnancies per AI? So everybody pretty much always says it's easier to improve the service rate. One of the things I wanted you to take home today is that we have ways now that we can improve the service rate and improve the fertility of the cows. So that's another kind of big concept. It's a relatively new concept, but we'll get into that. This is just a benchmark, a 21-day pregnancy rate. Notice this is 1998. Okay, so this is quite a while ago when we first started looking at pregnancy rates. You can see that across the x-axis is the pregnancy rate, and on the y-axis are the number of herds. This is data actually from Minnesota, so I kind of poked a little fun at the Minnesotans, but this is Minnesota data. So pretty similar to dairies in the upper Midwest. It's a normal distribution, and at that time the average of that distribution was 14%. I would say at this time the goal for most of our good dairies was to have a pregnancy rate above 20%. And in 1998, very few dairies could achieve that. How many of you would be happy with a 14% pregnancy rate today? Not many hands are going up, okay? So we've really, at the end of my talk, I'll show you, we've pushed this graph to the right. We've been able to increase pregnancy rate by increasing the service rate as well as pregnancies per AI. So I've shown this graph for years. This is data from a real dairy. And so x-axis, this is time, June of 2001 back to March 2000. So about 16 years ago. This is days in milk at first insemination. I drew a line at 50 days, and I drew a line at 100 days. So this is, each red box represents a cow. This is a graphical representation of question 1. How is this dairy doing at getting semen into their cows at the end of the voluntary waiting period? So would you guys say this is good or is this bad? This is not so good. So what is their voluntary waiting period?
55 days.
Yeah, if you went to this dairy, they'd probably tell you 55, but why are they breeding cows early? There's one thing that motivates that decision. It's called fear. On this dairy, if my best cow comes into heat before the end of the voluntary waiting period and I don't breed her, she may end up being one of these cows inseminated for the first time after 100 days in milk. And so it forces them to breed cows too early. What's bad about breeding cows too early? It's probably not economically the best time to get cows pregnant, and you're going to have lower conception rates if you breed before 50 days than if you breed after 50 days, probably due to uterine involution. Okay? So just keep in mind, about 30% of the cows on this dairy don't have a chance to get pregnant before 100 days because they haven't been inseminated before 100 days. Do you see how this is a service rate problem? The way I like to state this dairy has very little control over their voluntary waiting period. They have very little control over the maximum days in milk a cow goes before she gets inseminated. So here's how I frame the problem. We've got a detection of estrus problem, which is a people problem, really. This is just what we used to talk about a lot in reproduction. How do we get people to watch for heat better? But we also have an expression of estrus problem, which is a cow problem. We have both. I want to talk first about the cow problem, then about the people problem, then we'll go back to the cow problem. Again, this is data from the University of Wisconsin, a study that I was involved with, that Milo Wiltbank was working on, and we simply looked at milk production near the time of estrus. These cows were not synchronized. They were allowed to come into behavioral estrus. Milk production at the time of estrus. Now, I apologize for all of you here in the United States. We're like the only country that doesn't use the metric system, okay? Kilograms per day. Just double it and add just a little bit more to that, okay? So these cows are given well over 100 pounds here, 120 pounds in this particular group. This is duration of estrus from the first standing event to the last standing event. What relationship do you guys see on that graph? As milk production goes up, the duration of estrus in these high-producing dairy cows actually decreases. Why would it do that? If you go back to the liver metabolism hypothesis, it's because high-producing dairy cows have higher feed intake and they're metabolizing more estrogen in the liver. So it compresses the period of time the cows are in heat. And it's hard to catch those cows in heat when they're only in heat for 2.8 hours every 21 days. So it's a problem that the cow presents that hampers us. Now, which cows do you want to get pregnant? Yeah, the cows on the right. And they're the hardest ones to catch in heat because of this liver metabolism hypothesis. So we have ways that we've tried to increase the people problem. So we've got KMAR devices, we got tail chalk, we have tail paint. These are all methods to help with the people problem, right? When people aren't watching them, it's an indicator that the cow was in heat. We can spend a lot of money on this problem. We have pedometry systems. This is the old heat watch system, okay? So again, is this addressing the cow problem or the people problem? This is dealing with the people problem. We even get desperate when we talk about the people problem. Do you guys know that you can train dogs to detect estrus in dairy cattle? They did that in this particular study. Now, how many of you have Labrador retrievers at home? Somebody has to have a Labrador retriever. How many colors of Labrador retriever are there? What are they? Brown, black, and yellow. I'm going to argue there's 4 different colors. We got the black, the yellow, the chocolate, and that's the meth lab. This is my dog. So you can tell what she is. She's a black meth lab. That's what I like to call her. She's the black meth lab. So anyhow, they trained these dogs to detect estrus. So they had 3 cows, 1 in estrus, the other 2 between day 6 and 12, so they would have CL, they wouldn't come to estrus. And then they had 12 sessions of testing with these dogs. 4 trained dogs averaged 87.3% correct detection of estrus. The dog is an amazing animal. The olfactory system of that dog is an amazing thing. But does this help the cow problem, or is this a people problem again? This is the people problem. Here's the cow problem. This is a study that we did a number of years ago. We had 5,818 records or cows, 13 studies in 8 herds. We can measure the proportion of cows that are not cycling at the end of the voluntary waiting period. Okay, so we call them anovular cows. They're impossible to catch in estrus because they're not reproductively cycling. And in this study, the prevalence of anovulation was 23.3%. It's almost 1 in 4 of your cows is not cycling at the end of the voluntary waiting period. So here's the implications of that. I don't care how well you watch for heat. I don't care how much you invest in technologies to detect estrus. You will never, ever catch all of your cows in heat. We have this population of non-cycling cows. And I don't know if people don't realize this or don't think about it, but they're not all cycling, and it's not a small population. Now, this is interesting. It ranged between 7.3 and 41.7% across dairies. No, that's a really good question. The question was, will a bull catch those cows in heat? No, because they're not cycling. Okay, they're just not cycling. So it's impossible to breed them to an estrus. Okay, so that's a big problem. That's the problem that the cow presents. They're not cystic cows, so that's another question. Okay, we distinguish between anovular cows and cystic cows. Cystic cows are a very, very specific definition of a cow that's in estrus over a number of period of days and things. Most of our cows that would be called cystic are not that way. They just have a big structure on the ovary that's benign and it's not doing anything. I prefer to refer to those cows not as cystic but as not cycling. I prefer to classify them that way, and we can talk about that in a few minutes. This was the first method that came along about 21 years ago that allowed us to deal with the cow problem. This is Milo Wiltbank's first paper with his student at the time, Richard Persley, at Michigan State University, and he's at Michigan State now. And so these guys developed this protocol. What do we call that protocol? That's an OVSync protocol. It uses a combination of GnRH and prostaglandin in these 3 treatments. Now we can do a timed artificial insemination without having to see the cow in heat. This was a big deal when it came out because a lot of reproductive biologists had been working on a way to do this. This was the second study these guys did. So again, Persley and Wiltbank, this is 1997 now, and they went to a commercial dairy farm. They split the cows into 2 groups. One group, they said, watch, do what you normally do. So they watched for heat, and so this is the voluntary waiting period. None of the cows have been inseminated. And you can see day by day, they watch for heat. They get cows inseminated. But at 100 days in milk, there's still 30% that haven't been inseminated. It's the same kind of data I showed you. With an off-sync protocol, they could go out and they could submit 100% of the cows within 7 days of the end of the voluntary waiting period, independent of their cyclicity status. And the major aspect of this study, pregnancies per AI did not differ between estrus and off-sync. So this was kind of the fulfillment of a long period of reproductive biological research in how can we do a timed insemination and do a timed insemination with equal fertility to estrus, and these guys got it done. So off-sync came out a long time ago. Researchers continued to work on this. It was a classic kind of what we would call paradigm shift. This is 2001, so a few years later, the group down in Florida. What we learned is that if we could start an off-sync protocol, if I could choose a day to start an off-sync protocol, I would choose day 6 or 7 of the estrus cycle to start. And what these guys said is we'll use an old synchronization program that uses 2 prostaglandin treatments 14 days apart. And at this time, before off-sync came out, a lot of people were giving prostaglandin every 14 days in the breeding pens, trying to bring those cows into heat. You guys remember that? How many of you did that? That was very common to do that at that time. I could go to the dairy and I'd say, yeah, go ahead, you do that, you breed cows, but then rather than giving the 3rd prostaglandin, let's just roll her into an off-sync, and you get a pre-sync off-sync program all set up. This is probably the most popular protocol used. I get to go to a lot of different countries in North America, South America, Europe, Asia. This most popular program out there used to submit cows for first insemination. I like to show these on a calendar. It's very clear what you have to do. Here's Wednesday, the cows are getting the prostaglandins. 12 days later on a Monday, you start off-sync. Thursday, a lot of cows are getting a timed artificial insemination. The first study with this protocol, they did 100% timed AI and compared pre-sync off-sync to just off-sync, okay? And they had to take out the non-cycling cows, which amazingly was 23%, which I told you in our big study, that's exactly what it was, 23%. When they took those anovular cows out, pre-synchronization increased fertility to an off-sync protocol. And so the industry really got a hold of this, and the fun thing that I get to do is I get to have kind of 1 foot in the ivory tower of academia and 1 foot hopefully out in the real world. And it's always fun to see how you guys incorporate some of these technologies, okay? So many farms would start to breed cows to estrus after that 2nd prostaglandin, and then only the cows that you don't see in heat go through. And so if I go to farms, this is a very common strategy for putting semen into cows for the first time. It's a classic pre-sync off-sync protocol. First prostaglandin is given about day 36. You don't breed after that one. Some cows will come into heat, but you don't breed. Give the 2nd prostaglandin at your voluntary waiting period, which is day 50. All of these purple cows are bred for the first time to an estrus, and then anything not inseminated flows into the off-sync program, and now all those cows are set up with an off-sync protocol. Can you see what we've done now? We've taken all the variation out, and we've started to control when we put semen into cows for the first time. Cows are not getting out too far before they get exposed to the risk of becoming pregnant, which is having semen put into them. Okay? Now here's another big concept. Again, if I was at UW-Madison, I'd say this is on the quiz. This is a great program to get semen into cows. It will not give you the highest fertility we can get to a timed insemination. So I'll repeat that. Great strategy for getting semen into cows, but typically we don't see really high fertility or pregnancies per AI in this program. There's reasons for that. Fertility to estrus, which I'll show you in a few minutes, ranges somewhere in the 30 to 40% range. It ranges among farms. Some farms it's a little higher than 40%. Sometimes it's lower than 30%. But that's kind of where the conception rate of these high-producing dairy cows is. Which cows then do you put on off-sync? So you breed all the cows that are showing estrus. Which cows go into off-sync? All the non-cycling cows. Now, amazingly, conception rate's not 0 in this group. It tends to be mid-20s, maybe the high 20s. Sometimes it can get into the low 30s. But the point is, we're putting semen into cows at a conception rate well below 50%. Okay? So the concept here, now, a lot of you may be thinking, well, we have these new technologies. My former student, Julio Giordano, and I put together a paper that we presented earlier this year at this conference in Chicago. And really, these automated estrus detection systems have become very popular. How many of you have a heat detection system at home? Yeah, they're very, very popular. And just, I want to be clear on this. I think they're great tools to help us breed cows that are showing estrus. They don't deal with the non-cycling cows. Okay, they don't deal with that. And so I just show you a graph. Now, I've gotten a lot of these in the mail. This is how not to manage first service. So this is a dairy. You can tell right at this period of time, classic pre-sync, off-sync. They breed to estrus and they go into off-sync. What percentage of cows are inseminated for the first time here? 100%. Can anybody tell me on this graph where the dairy said, aha, we've got this new heat detection system and we don't have to synchronize cows anymore? Can anybody see where that happened? Yeah, I tried this with my kids at home. They found right there, okay? And so now you breed a lot of cows, but you don't breed them all. And here's the old problem. A lot of cows are going past 100 days or 80 days here, but guess what percentage of cows that you are inseminating at this period of time? Only about 70%. About 30% of the cows aren't cycling, and you're not catching those. And then I went out to the dairy at this point, and I said, wait a minute. You know, nobody ever said that you have to do 100% timed AI, but nobody ever said that you had to do 100% estrus detection. And so let's blend the technologies. That's probably my message with this part of the talk. If we blend these technologies, it's probably a much better way to go. They're actually using the heat detection system to catch cows in heat, and then they're dealing with the non-cycling cows with off-sync. And I always tell people with these systems, the system will identify the cycling cows, but by doing that, it identifies the population of cows that aren't cycling that you need to do something with. And waiting to do something with those cows is probably not the best way to go. Being aggressive with those cows would be a better way to go. Okay, so remember I told you that there's a number of different ways to approach first service. This is a 2,000 cow dairy in Minnesota, and they're doing something not as popular, but it works really well for them. What they do is a pre-sync, off-sync. They give the first prostaglandin at 50 days, and look at the cows they breed. And then 14 days later, they give prostaglandin and breed cows. And now only the cows that they haven't seen in estrus after those 2 prostaglandins are submitted to an off-sync program. Their strategy is to maximize estrus detection and minimize timed AI. Notice that they're not eliminating timed AI. On this dairy, I think maybe 15 to 20% of the cows make it to an off-sync protocol. Again, now I want to point out, their 21-day pregnancy rate is 25%. That is a good 21-day pregnancy rate. I would never go to this dairy and say, do something different. They've got a plan in place for first breeding that works. They get that 25% pregnancy rate by getting a high service rate. In other words, they're putting a lot of semen into cows, but look at the pregnancies per AI. It's 38%. And notice the parity effect. First lactation animals always have the high fertility. It's always these older cows that present the fertility challenge. Okay, so again, it's a good strategy. They're focusing on getting semen into cows, but they really haven't got a way with this kind of a system when you're breeding a lot of cows to estrus to deal with the fertility issue. I want to switch gears now. We've talked a lot about service rate. Now I want to talk about what I would call fertility programs. So here's our pre-sync, off-sync program. Remember, the strategy is what day of the cycle would I want to start off-sync? What did I say? This is quiz time. Day 6 or day 7, okay? The cows that come into estrus after this prostaglandin are the ones that are set up to be day 6 and day 7. If you breed them to estrus, you pull them out of the program and you lose the pre-sync effect. Okay, that's really what's happening when you add heat detection into this system. So what would happen if we didn't breed them? What would happen if we allowed all of our cows to flow through this to 100% timed AI? Now, there's a number of studies that have looked at that, and these guys from Germany, I love this study. First of all, it's from Germany. It's got to be good, right? Second of all, they took 3 randomized controlled studies. One of them was mine, okay? So again, it has to be a great meta-analysis if they included my study, right? So they took these 3 randomized controlled studies, 1,689 cows. So that means half the cows got pre-sync off-sync with no heat detection. Half the cows got pre-sync off-sync with heat detection. And what they did in their analysis is they found that if you breed cows to estrus during a pre-sync off-sync protocol, it decreases the odds of pregnancy by 35%. So I'm trying to introduce the concept and the reason why some farms are deciding now for first insemination to do a 100% timed AI program. It's because we can get higher fertility than breeding those cows to estrus. This is one of those fertility programs. It's a double OBSYNC program. How many of you have heard of double OBSYNC? Okay, so many of you have. Keep in mind that a non-cycling cow doesn't have a corpus luteum, right? By definition, they don't have a corpus luteum. 2 prostaglandin treatments do nothing, relatively nothing, for cows that don't have a CL. It ends up that if you combine GnRH and prostaglandin, so they're using an OBSYNC protocol for pre-synchronization, and it ends up that if you give a GnRH treatment to an anovular cow or a cystic cow, about 90% of them will ovulate a follicle. And if they ovulate a follicle, they'll form a corpus luteum, we regress it. And if we can get 90% of the cows to ovulate here, what day of the cycle do 90% of the cows start off-sync? Exactly day 7. So I think people look at these protocols sometimes and they think, yeah, that's complicated. I wonder why it's so involved. Well, we know that they're involved, and one of the things we'd like to do is to simplify them, but we've done some work in that area. But if you do that, you resolve the anovular condition in the anovular cows, and you get a lot of cows to exactly day 7 of the cycle. And so it really does those 2 things quite well. Now, how is this farm doing at getting their cows inseminated for the first time? So this is, they have a voluntary waiting period about, I can't even read, I'm up here and I can't even read that number. It's about 64 days. Within a week of the end of the voluntary waiting period, almost 100% of their cows are inseminated. So that's the service rate part of the equation. The other part of the equation is we can get conception rates close to 50%. So with this kind of a strategy, you can get half of your cows pregnant at first insemination. And it's the reason that this is getting incorporated is not because it's easy, but because it works, okay? It manipulates the physiology of the cow such that we can overcome some of her problems. Just to show you, this is our more recent data, a study that we're in the midst of analyzing. And what we did, this is a double OBSYNC program up on top here. Really what this program is, it's 2 prostaglandins 14 days apart. We added the second prostaglandin, I'll talk about that to match that. But this program was meant to breed cows to estrus. It synchronized them for estrus. This cow synchronized them for timed insemination. Look at the conception rate to double OBSYNC. This is in the same herd. Cows are randomized within the same dairy farm. 50% conception rate to double OBSYNC, 39% conception rate to estrus. No CEDARs. You don't really need a CEDAR in a double OBSYNC because it really ovulates follicles and it uses the corpus luteum to secrete progesterone. I'll talk about CEDARs in just a minute. But don't lose sight of the fact that we bred 100% of the cows in this group. That's the service rate side again. This is the fertility side. So we inseminate 100% of them and get half of them pregnant. We inseminate about 77% of them and get 39% pregnant. So really, this kind of illustrates the power of being able to breed cows with high fertility and the advantages of doing that. One of the second studies, this is Milo Wiltbank's data, pre-sync off-sync versus double off-sync. There's always a parity effect. You can see the younger animals, they increase 48 to 53. The older cows increased a little bit, 36 to 40. So it's just showing you that you do get somewhat of an increase with double off-sync. But if you look at these data, notice what the issue is here. Why are the older cows so much lower in fertility than the younger cows? And so we started to kind of ask that question. Why is it that we're getting such low fertility on the very same protocol as compared to those first lactation animals? And really to answer that question, we've done a lot of work with taking blood samples. So this is an OFSYNC program. The students that are in the room, you guys know exactly what this is like to do this, right? So you're taking blood samples at each of these times, and we can analyze progesterone. So you guys got to stick with me on this one. I'm going to show you data. Again, this is a really big concept. When we give prostaglandin, what does prostaglandin do to the CL? It regresses the CL. What produces progesterone? The CL. So then progesterone should be high or low at this time? Should be low. We want the progesterone to be extremely low at this particular period of time. So I'm going to show you what, this is data that my former student put together from a lot of the data we have at UW-Madison. Over 3,000 cows. Each cow had one blood sample at that G2, we call it, and we looked at progesterone. Notice that if they have low progesterone over here, fertility's not too bad. Okay, now this is on a variety of different protocols. But the important thing to notice is if there's just a little bit of progesterone around at the time of the second GnRH treatment, you really crash conception rates in those cows. So let me try to explain a little bit of the physiology, what we think is going on. How many of you have ever inseminated a cow? Inseminated a cow. What is the site of semen deposition? Where do you put the semen? In the uterine body. Okay. What is the site of fertilization? Not the horn. It's in the oviduct, halfway down at the ampullary isthmic junction. How does sperm get from the body of the uterus to the ampullary isthmic junction? I tricked you into saying it swims. Okay, it does swim. It does swim. But if you actually take semen from a bowl, and let's say you microwave it and kill it. I'm not recommending that you do this at home, okay? But let's say you kill that sperm and you inseminate a cow in estrus, it gets to the site of fertilization just fine. It's mostly the female reproductive tract that does that transport, but it has to occur in a low progesterone environment. What's happening here is that the CL in some of these cows is not fully regressing or regressing quick enough, and this progesterone is probably causing a problem with that sperm transport and fertilization rates. Is everybody still with me here? So how do we fix this problem? Yeah, more prostaglandin. So what has been done? Now again, the question in the laboratory is, what is limiting fertility in these lactating dairy cows? Can we get fertility higher if we manipulate the cycle in the appropriate ways? One of the other things I didn't tell you guys, this double OFSYNC program, if you have a CL here and a CL here, you get higher progesterone during the growth of the follicle, which we also think is good in a cow with high progesterone metabolism. What we've done is we've added the second prostaglandin 24 hours after the first one there. How many have done this? Anybody in here done that? Did you see an effect when you did this? It's a big enough effect that I think that you see it. Now, these numbers are small, so I'll read them. Again, some of Milo's work. If you give one prostaglandin to first lactation cows in a double OFSYNC, 46%. It went to 48% with the second one. Here's the older cows, though, 36.6 to 45%. So the big gain is the older cows. They're the ones that aren't regressing those CL very well. You can see Milo calculated the increase in pregnancies produced is just under 5% in the first lactation cows, and it's 23% in the older cows. So the point is we've got a way now that we can get fairly high fertility in lactating dairy cows. When I know of farms that have added that second prostaglandin, they typically see it's a big enough response that they actually see it. Some of the people out there have questions for me. It's a lot of work to give that second prostaglandin. What if I just increase the dose? Have you guys ever wondered that? What if I just increase that dose? We just finished this study. It's not published yet. But what we did is we had OVSync with one prostaglandin. We had the two 24 hours apart, or we just gave them a double dose. So this is Dynaprost. So that's the question. Can we just give twice the dose at one time as opposed to having it given 2 doses? Now, what I want you to understand, under normal physiology, when the CL regresses, it requires pulses of prostaglandin from the uterus. And it takes at least 4 pulses of prostaglandin over a period of time to regress the CL naturally. So increasing the dose doesn't really mimic that change in those pulses that happen. We looked at luteal regression. So this is the one prostaglandin. That's the double dose. Those are the two 24 hours apart. Not looking too good for the double dose at this particular point in time. This is done with Dynaprost. So I'm not saying cloprostenol would get the job done. I just have to be clear. This was done with Dynaprost. These are conception rates then. No statistical differences. We had almost 450 cows per treatment. And again, the numbers follow the luteal regression, but it just doesn't appear that doubling that dose does anything near what giving the second prostaglandin. I put these in my slides because last night somebody told me that there's a group that's increasing the dose of prostaglandin, and I'm just a little skeptical about that. Yeah?
I don't want to get you in trouble, but any difference between luteinized and espremate?
So the way I answer that question is for you guys, the question really is, if I use one or the other in a synchronization program, do I get more pregnancies? Is that a good interpretation of your question? If you look at all the data, I don't think you can say that there's any difference in pregnancies produced. That's not to say the molecules aren't different. That's not to say that there's some subtle differences there. But when you look at pregnancies produced, I don't think there's a difference.
The reason I asked that in this older group that were double treating,
Yep.
that were using espremate as a second shot,
Yep.
and we seem to notice an improvement in the older.
As opposed to using Dynaprost in the second shot? Yeah. Interesting. We haven't looked at that. We have a study now where we're doing some different things. Again, we're always kind of trying to push this a little bit forward. But for right now, I would say I think you need the 2 treatments 24 hours apart. Whatever you're doing, if it's working, I'd say keep doing it. But I'm not going to say there's scientific basis to do that. Yeah, question? Yeah, so good question up here. So the question is, I'll go back to Milo's work here. The question is, should I do it in my first lactation animals? They went from 46 to 48. Multiparous animals went to 36 to 45. So that's the no-brainer group, the older cows. Okay? The question is the younger cows. But here's how I answer that question. What is the value of a pregnancy? If you could put a value, if you had a magic reproduction wand in your hand, and you could walk up to your cow at the end of the voluntary waiting period, tap her on the head, and make her pregnant, how much money have you just made? This isn't the value of the calf. It's just the future value of the milk produced. What would you guys say? Is it more than a shot of prostaglandin? That's how you should think about that question. Okay, it's a lot more. I mean, it's like hundreds of dollars value of a pregnancy, $2 for a treatment of prostaglandin. For 5% more pregnancies, in our herd, we've done it to all cows. But it's your choice. But that's how I think about it.
You don't do it selectively like the second option or anything. These people are just doing
I'm talking about first breeding now, and so we'll talk about resyncs in just a minute. Okay. So there's good questions and there's great questions. You guys know the difference? A good question I know the answer to. A great question I have a slide that I can show. Okay, so it's a great question. I'm going to show you a slide in a few minutes. All right, so where are we with time? You guys good with time? I'm way more than halfway through. So we've talked about first breeding. We've talked about these fertility programs. I want to briefly talk about this non-pregnancy diagnosis and then re-insemination. Okay, so why do you do preg checks on your farm? What is the purpose of doing a pregnancy diagnosis? What are you looking for? You're not looking for pregnancies. You're looking for which of my cows are not pregnant and what am I going to do with them, right? So identify non-pregnant cows and rapidly return those cows to an AI service. That's really the purpose. So it makes you warm and fuzzy inside when you go, wow, that cow's pregnant. Good deal, you know. Or sometimes the farm I grew up on, the cows you want to get rid of are always the cows that get pregnant, right? They always are the cows that get pregnant. Yeah, that's exactly right. So here's how this is just briefly the resync that we do. So here's an insemination. You can put semen into your cows, however you do it. And then the earliest non-pregnancy diagnosis you can do is to catch those cows coming back into estrus. For the farms that have invested in heat detection systems, they listen to what I say about first breeding and they say, well, you just want me to throw my system away. No. I think a great way to use those heat detection systems is right there. You may get a little lower fertility on these estrus breedings, but you get those pregnancies so much earlier that I think it's a really valuable way to go. Notice most of the heat is done by day 32, so we come in with GnRH. Day 39, pregnancy diagnosis. Give them prostaglandin if they're open. And now we have step 2 in place. We have a lot of farms then that have adopted that kind of a resynchronization strategy to deal with these non-pregnant cows. Another thing we got to talk about with non-pregnancy diagnosis, pregnancy loss. How many of you ever had a cow diagnosed pregnant and then she's open? You guys lose a lot of sleep over those cows. I know you do, okay? We don't think pregnancy loss in lactating dairy cows is necessarily due to diseases, infections, those kinds of things. But this is kind of the rate of loss from 28 days with ultrasound. Look at that loss to day 70. It's about 16%. By day 70, there's an inflection point. From 70 to calving, it's a lot lower, okay? And so most of our farms now, this is just the timing of preg checks. An early check, I would say 32 to 39 days is the way that I would go. 28 days later or 4 weeks later, you recheck all the cows. Again, you will never catch all of your open cows coming back into heat. That's I don't have time to cover that data. We have some interesting data on that. Even if you have a heat detection system, a lot of cows that lose pregnancies, it won't detect them. Okay, they're either ovulating without showing signs of estrus, so they go back into this anovular condition. And then most people are going to check out here at dry off. How many of you do multiple preg checks? Really important, because you guys find open cows there. You guys find some open cows there. So direct methods of pregnancy diagnosis would be like palpation and ultrasound. How many of you use palpation and ultrasound? Palpation and ultrasound. Very popular. How many of you use these new chemical tests? Anybody using milk or blood? So these are relatively new. So these are what I call indirect tests. They're qualitative or quantitative measures of hormones or conceptus-specific substances. Now, everybody knows about these tests, right? This is actually hormonal changes in women during pregnancy. There's a special hormone called human chorionic gonadotropin that gets very high very early. It crosses the kidney and gets excreted in the urine, so we can have all these very sensitive tests in humans for pregnancy. The problem is primates and equids are the only species that produce a chorionic gonadotropin. So in women, we have human chorionic gonadotropin. In mares, we have equine chorionic gonadotropin. So people have always asked, why? Here's the test. You guys know about these, right? It's the, oh, I'm pregnant, oh, I'm not test, right? You know, when I have 3 kids, when my wife thought she was pregnant, we went to the doctor. The doctor doesn't do any rocket science to do this. He runs one of these tests if it's early. Okay, they're that accurate, 99.9% accurate, you know. And so here's how they work. The most sensitive test can detect HCG around the time of implantation, which is 8 to 10 days after an ovulation. A new reproductive cycle occurs about 14 days after ovulation. So the likelihood of a false negative is very low once the onset of a new cycle is late. Now, my daughters would just call this bonus information. I'm just giving you guys some bonus information today how these things work. But the question is, why can't we do this in cattle? They don't have a chorionic gonadotropin. So people have looked for a long time for different ways to do this. This is 1982. First paper that really defined this protein is called pregnancy-specific protein B. That's because pregnancy-specific protein A wasn't a novel protein. So it was the second protein they identified. It was a new class of protein secreted by the conceptus, so it's very specific for pregnancy. The next thing they did in 1986, they developed a way to measure it. And they measured it in 5 pregnant heifers. Notice it comes out, starts coming up about day 25 to 28. It peaks. It comes back down, gets very high at parturition. And so here's what you have to do to run these tests. Earliest preg tests are 28 to 30 days, which competes directly with what technology? Ultrasound. And then it takes 60 days post-calving to get the PAGs out of circulation that were there from the previous pregnancy. So those are the 2 things you have to do. This is what the test looks like. It's a ELISA. So these are samples from a cow on day 20, 22, 25, 27. When do you see the color change? When do you guys see it? You see it at day 25? Yeah, it's starting to light up at day 25. You don't need a reader. This is meant just to look at it. You set it on a piece of paper and you just look at it. So it's a neat technology that's out there. We've tested it. So we did a resync protocol, and on day 27 we took ultrasound and PAG, and the accuracy of these tests is very high, in the high 90s, mid to high 90s. Now this is day 27. If we'd have done this on day 29 or 30, it'd probably be closer to 98%. Okay, so just keep in mind, people worry about it's not 100%, but no analytical test is 100%. This is high enough to use really well. These PAGs now, this is PAGs in milk, and this is PAGs in plasma of pregnant cows. There's a pattern, and notice when it peaks. It peaks at day 32. That's a really nice time to test these cows. If you test them out in here, you can get some rechecks or false negatives, which would be really bad on a preg test. So a lot of different things affect these PAGs, and we've looked at that. Just progesterone, the only thing I would say with this, the technology that's coming, that's not quite here yet, if I knew progesterone every time a cow is milked, I think it's going to radically change the way we manage reproduction in dairy cows. So this is a progesterone profile after breeding in a cow, and this is, which one's pregnant, the top one or the bottom one? The bottom one. She was inseminated, the CL grew up and stayed up. I never had to put my arm in this cow to determine her pregnancy status. So this is the kind of technology that's coming. I don't know when it's coming here in the United States, but in some countries they have the ability to do this, but that's just something to watch out for. Okay, last thing I want to show you is this. This has to do with the resync, so we'll talk briefly about that. Here's a herd. First breeding, 47% conception rate. Second, third, fourth, fifth, and sixth, somewhere in the 30%. How many of you see a pattern like this on your dairy? Anybody see that pattern? That's frustrating. So some of the work that I've done has been, why can we get such high fertility? Why do you think fertility is so high at first breeding in this herd? Double OVSync. That's exactly what I was waiting for somebody to say. That's our fertility program. So this is double OVSync for first breeding, and then the resyncs just don't do very well. Okay? So what we've done, this is a resync, and we've added that second prostaglandin in a pretty good group of cows. 27% if you just resync them, 35% if you add that second prostaglandin. I think we can get that number higher. This is across a number of different studies. So I think adding the second prostaglandin to the resync programs is beneficial for those cows within a certain context. How many of you use CEDARs? How do you use them? Okay, most people will put a CEDAR in during an OVSync protocol, and that's what we did. We tested that. Notice that without a CEDAR, if they had a CL at G1 versus if they didn't, so the no CL cows have the low fertility. You add a CEDAR to those no CL cows, you increase it. Okay, so my best recommendation for use of CEDARs is in a no CL cow. So just to wrap up, this is our dairy at the University of Wisconsin-Madison, up at Arlington, not far from here. We have about 550 cows. And what we did is we said, how high can we get the 21-day pregnancy rate? So I'm going to take all the information I just shared with you guys over the last about 55 minutes, and I'm going to just try to get the highest preg rate I can get. So what do you think I'm going to do for first breeding? Okay, so that's what is done on this dairy. It's a double OVSync with the second prostaglandin. It's 100% timed AI. The benefit, 100% of cows get inseminated within 7 days of the voluntary waiting period, and we get about half of them pregnant. Here's the resync scheme. Now, what we did is we had a series of lab meetings. We argued about this, what is based on what we know. I would call this kind of a fertility strategy for second and greater breeding. What we do at our dairy is we come in on day 25, set up with GnRH. You can do this on day 32 a week later. So 25 to 32, we're going to get set up with GnRH. We're going to do a preg check with ultrasound. We do it at day 32. The cows with the CL, we finish the protocol and do a timed AI. This is just an OVSync with the second prostaglandin. About 85 to 90% of the cows, if you set up with GnRH, will have a CL. About 10 to 15% of the cows won't have a CL, so we restart OVSync with a CEDAR and then just finish them off. So we're targeting the animals. Now, if I were to do this strategy, if I'm adding the second prostaglandin, I think it's important to include the CEDAR for the no-CL cows for reasons that I don't have time to get into today. But that's kind of how I would set it up. I know a lot of dairies that do this, and they do pretty well. So here's our reproductive program. First breeding, second breeding, third breeding. Within 100 days of the end of the voluntary waiting period, we give our cows 3 chances to get pregnant, 31% preg rate, 66% service rate. Our conception rate averages 50%. This is across the first 3 breedings. You can see 91% of the cows are pregnant after 3 inseminations. So when we get cows on this program, we get them pregnant very, very rapidly. In fact, if you're a cow on this dairy and you're not pregnant after the 3rd breeding, you're going to have a career change. Now, I said that to a group from India the other day, and they said, our cows don't have a career change. I said, okay, they retire then. They no longer are a dairy cow, okay? And so just this is the last slide, a talk I did late last year, 54 herds in Wisconsin, 40,000 cows. 2/3 of the cows have greater than a 20% preg rate. So we've shifted that whole curve. Notice that they don't all have high fertility. We still have herds with low preg rates. Not sure what the deal is with those herds, but we certainly do have the ability to get preg rates up. So with that, I'm going to stop, show you that particular slide, and I'm glad to take any questions that I can try to entertain at this point. So, okay, let's start with, thank you. All right, first question.
What do you recommend on your resyncs? So you check the cow after you did that GnRH on day 25, you check her at 32, no CL, CEDAR. I recheck those cows 7 days later. What do you do on those cows that aren't still cycling?
Okay, so we'll let anybody who has to leave can go ahead and do so. The question is a really good one, and it's one I get often, okay? So what you've done is you've done a preg check, you've identified the no-CL cows, you put a CEDAR in, you're checking them here. Okay, now, the effect of the CEDAR to improve fertility is not dependent on the presence of a CL. We don't check them here, okay? And the reason we don't is because in this particular study, we did not know anything other than whether they had a CL or not. We didn't recheck them, and the addition of the CEDAR improved fertility. So I would not get into where I'm out there probably looking at the pole that CEDAR. I would just finish them off on that program.
What I've been doing is just leaving the CEDAR in another week, and then a lot of times there'll be a CL the next week. So
Yeah.
I mean, that's kind of.
Keep in mind, though, if you have a CEDAR in these cows, they're not going to ovulate. So if you have, I mean, they might ovulate to that GnRH treatment. You might suppress that, but they're not going to come into heat during the CEDAR insertion. I would just stick with the protocol. That's exactly what we do. And when we did this, that's when we started to see high fertility in our herd. Any other questions? Yeah, that's on my website. If you guys Google me at UW-Madison, you get to my website. Those calendars are up there. Yeah.
When you put that CEDAR in there in that 7 days, what percent of the cows
Lose it?
come in when you?
Come into heat.
Yeah, when you put the CEDAR in, pull it, what percent comes in on that lose?
So if you wouldn't do that GnRH, what percent would just come in when you pull that loop? It's probably around, I have a grad student that what he did was he looked at cows coming back into estrus. They had a farm with a heat detection system. The veterinarian palpated or did ultrasound. The open cows with the CL, they gave prostaglandin and watched for heat for a week. It was less than 50% of the cows were caught in estrus. I'm just telling you that estrus is good to some extent in these high-producing dairy cows. But you got the cow problem and the people problem. One of the problems I didn't talk about, do we keep our cows on grass or concrete? Concrete. It's not a good surface for mounting. So there's all kinds of reasons why we don't catch a lot of our cows in estrus when we try to use prostaglandins. It's just, I know it's frustrating, but that's a big issue that we have there. Any other questions? So right up here, yeah.
The double shot of prostaglandin, is there any R&D being done on a
Long-acting?
Yeah.
Obviously, that's something that I think that the pharmaceutical industry has seen and is looking at. I would say that the issue is the timelines to get something like that approved. It takes years. It really does. It takes years. So, good question.
Two questions. Your preference of G6G versus double off, is there any difference? And second question, that your CL plus, should you let all those go to the timed AI if you should see a heat in between there? Should you breed that heat?
This one here?
Yeah.
So where you see, oh, on the CL plus, where do you see the heats? In here?
Well, yeah, anytime in there. Should we go all the strictly timed AI after the 16 hours?
Did you guys hear the question? Sometimes when you give this second prostaglandin, you get a few cows coming into heat a little early. So you get progesterone down very quickly, okay? If they're in heat early, I think that I would inseminate them and the rest of them let go to the timed AI, okay? Because when they're coming into heat, the clock starts ticking as far as when they're gonna ovulate. I don't think it'd hurt you to go ahead and breed those cows because really they should be kind of starting to come into heat about right there, and the timed AI is set about right for that. Now, I'd probably give the GnRH and breed them. Now the other question is with regard to G6G. Apologies to my good friend Richard Pursley. Are you from Michigan? Okay. Pursley has worked up a lot of the G6G. And this is a really important question, okay? Let me get back to a good slide where I'm looking at this here. Okay, so let's just look at this one. What if, okay, can you see that? What if I took this GnRH and I moved it there, and I took this prostaglandin and I moved it there, and I didn't do that GnRH? What is that? What is this? That's a G6G. What if I did a G6G, but I put that GnRH right there? Now what's that? Huh? It's a double OV-sync. Okay, so the point I want you guys to make, I think that sometimes people in their head, they've got, I'm a G6G guy. That's what I do. Or I'm a double OV-sync guy. Those two programs are not very different from each other. It's really just the interval between these two GnRH treatments and the fact that you don't give that GnRH. It's the combination of prostaglandin and GnRH that really helps those particular programs. And that's the way I think about them. They've been compared. I think that in non-cycling cows, I'd give a little bit of an edge to a full double OV-sync over a G6G. But let me tell you, there are herds out there that do really, really well with the G6G program. So it doesn't matter to me whether you're doing a G6G or a double OV-sync. So, any other questions? Yes. So that's an excellent question. Did you guys hear the question? I could give you guys another hour talk on twinning. In fact, I just put together a talk on twinning that I did at ABP last fall for the veterinarians. It ends up that the reason for increased twinning is associated with this increase in milk production and the subsequent decrease in progesterone right around the time these follicles are getting selected. So what's happening in these high-producing dairy cows? They're double ovulating at a higher rate. The increase in twinning is not due to identical twins. It's due to codominant follicles in the two twins, okay? It also ends up that double OBSYNC is the best way probably to decrease that twinning rate because it manipulates progesterone back up during that period of time. So I know that's confusing, and what people think is, well, my little sister, for example, she has twins. Well, she has twins because she underwent assisted fertility treatments. So what do they do for assisted fertility treatments? They use hormones, right? So people say, well, we're using all these hormones in dairy cows, that's what's causing the twinning. It actually ends up that if you do a double OBSYNC, you can decrease it. Now, here's another thing. It's complicated. If you put all your no-CL cows on an OBSYNC program, which is what some people do, it's a big mistake. So they go through, they do preg checks. Cows with a CL, they give prostaglandin. Cows without a CL, they put on OBSYNC. That's backwards, okay? If you put cows with no CL on an OBSYNC program and you give the second prostaglandin, you'll increase the rate of double ovulation and twinning in that group of cows too. That's why the CEDAR is so important in that resync program to get that progesterone up during that time period. So the twinning thing is an interest that we have. I think we can get around some of it, but these high-producing dairy cows, as they go along, just be careful. If you're putting the no-CL cows on OBSYNC with the second prostaglandin, I'd put a CEDAR in those cows too to try to get that down. So good, got a nod head out there. That's great. Good, good. You followed me through that. Other questions?
You have your breeding program for the research farm. Do you have that on an Excel spreadsheet where you plug in the date and it fills in the calendar?
Nope. So the question is, the breeding program that I showed you for our herd, do we have a Excel spreadsheet for that? We don't, unfortunately. Most herds that are doing this have some kind of a software system, that whether it's DairyComp, DHI Plus, whatever you're using, it's an important part of use of those programs is setting those protocols up. So last thing I'll leave you guys with is the cows, and I didn't have time to include this, cows have to be healthy to get the kind of fertility that I'm showing you. If you put high somatic cell scores on these programs, if they lose a lot of body condition post-calving, you're going to have lower results. Good reproduction allows you to have a better herd of cows that eventually helps you to get fertility up in the herd. So there's one other question over here. Yeah.
Pedometers and you use activity and that sort of thing. And you don't worry much about natural breeding from those. You go right to an OBSYNC program even if you have pedometers and watch the activity.
So the question is, if you have a pedometry system, how would I run reproduction? That's kind of the question, right? So, yeah. So again, I'll go back to what I said early in my talk. I don't think there is only one way to do this. The first question I ask when I go onto a dairy, to the owner, to the manager, what's your goal? What's your goal on this farm? Some farms, the goal is to minimize use of these programs, okay? If that's your goal, then you have to set up a system to use the heat detection system for first breeding and then only use a really effective program to deal with the non-cycling cows. Some people want a really high preg rate. And based on my talk, the advantages of 100% timed AI to that program I showed you, a double OBSYNC with a second prostaglandin for first breeding, it's a great way to start out for a high preg rate. I would use the system, like I said, after that first breeding and then use that to detect the cows coming back into heat. See, I mean, but there's different ways you can do it. Okay, there's different ways you can do it. Remember what I showed you. Cows that come into estrus, high-producing cows that come into estrus have pretty low conception rates. I mean, relatively low conception rates. So when I go to a dairy that's doing kind of a lot of heat detection and they say, look, my preg rate is 22% and I can't get it any higher, and I usually just say the program you have in place is going to give you about that 22%. You have to have some way to get fertility up, and to do that, that's where you have to use the fertility programs. So, man, you guys are hardcore sticking around here. That's great. One more question, yeah.
Cost comparisons. Have you done studies on your type of programs versus, because you can do fairly cheap, like say, for instance, I do all blood test pregnancies.
Yep.
So I'm not going to be able to identify
CL or no CL.
plus or minus.
Yeah, that's the one limitation.
Okay, so we can go in and say, all right, what are the benefits financially of having the vet come out versus paying $2.40 a cow to get her tested?
Yeah. There's a tool on the web that my colleague Victor Cabrera has. If you go to UW-Madison, you Google Victor Cabrera, you can download a spreadsheet, and what you can do, it's a spreadsheet-based model, but it's a complicated model. You can put in all these parameters. What if in my Resync program I can increase it by 5%? Then you can compare your program to a modified program, and it will give you kind of dollars per cow per year. That it's just models aren't perfect, and they're kind of frustrating to work with, but there's ways to ask those kind of questions, and we've developed some tools that you can do that. So that's about as good as I can answer that question right here, yeah. All right, you guys, thanks so much for coming to my seminar. Thanks for coming out to World Dairy Expo.
I just want to remind everybody, too, that the presentation will be on the World Dairy Expo website by this evening. It'll be uploaded there, so if you want to go back and fine-tune what you remember, it's posted. And on behalf of Feed Supervisor, we want to thank everybody for coming and thank Dr. Fricke for his presentation. So enjoy the rest of your day. Goodbye.